Hi, welcome to Raw Math. Today I'm doing a series of videos on functions and specifically on this one, graphing a piecewise function. A piecewise function is a function that is defined as two or more functions dependent on where you are in the domain of the graph. Okay, so what I'm going to do is I'm going to plot a bunch of points and then I'm going to plot them on the graph and then see what happens. Our breakoff point is 0, so I'm going to denote that so I don't get carried away. And then for 0, I'm going to put 0 into both equations because I'm going to need to do that. For the first one, I'm going to graph an open hole because it doesn't equal, and on the second one, I'll do a closed hole because it does equal. Okay, so if I put in -3 for my first equation, I have 1/2 absolute value of -3 plus 1, which is 1/2 times the absolute value of -2. This means it's positive, so this is 1/2 times +2, which comes out as a +1. All right, so we have 1/2 times the absolute value of -2 plus 1, which is 1/2 times the absolute value of -1, which is 1/2 times +1. I'm going to put this in here as 0.5 because when I graph, decimals are simpler to graph. 1/2 times the absolute value of -1 plus 1 is equal to 1/2 times the absolute value of 0, which is just 0. And then for this graph's version of 0, 1/2 times the absolute value of 0 plus 1 is 1/2 times the absolute value of 1, which is just 1/2 times 1, which is 0.5. So these are the 4 points I'm going to plot. That doesn't mean this is where it starts. I could have gone -4, -5, -6. So this will need an arrow to the left, not to the right, but to the left, just like this one will need an arrow to the right. Let's start at 0 for this one, and I'm going to do this right below the table so that I have room to do these 3 on the table. So for the 0, it's going to be the square root of 2 times 0 minus 1, which is going to be the square root of 0 minus 1, which is the square root of -1, which does not exist. Which lends the question, where does this graph start? Where does the domain start for this square root? The way I figure that out is, so for the domain, is I take 2x minus 1, and that has to be greater than or equal to 0. For a square root problem, whatever is underneath the square root has to be greater than or equal to 0. I'm going to add 1 to both sides. And that tells me that 2x has to be greater than or equal to 1. Divide by 2, and x has to be greater than or equal to 1/2. Okay, so if x is 1/2, that's, since we did this for 0, that means 1/2 0 is a point. So I don't have a 0, but I have the 1/2 0 that I could plot. It gives me another point to graph and a starting point for this graph. All right, let's look at 1. Square root of 2 times 1 minus 1 is the square root of 2 minus 1, which is the square root of 1, which is 1. Square root of 2 times 2 minus 1 is the square root of 4 minus 1, which is the square root of 3. The square root of 3 is about 1.73. I jumped up to 5 because honestly, I wanted to make sure we had values we could graph on grid points. The square root of 2 times 5 minus 1 is the square root of 10 minus 1, which is the square root of 9, which is 3. Okay, this gives us way more than enough points to graph. We start at -3, 1, then -2, 1/2, -1, 0, and then at 0, 1/2, we have an open hole. Now, if you remember, I told you that we're going to do an arrow over here because this wasn't a stopping point. This would go on and on and on. This is infinitely going in this leftward direction. Okay, now there isn't a 0 for the second graph. It starts at 1/2, 0. So at 1/2, 0 right here. Then we have 1, 1, 2, 1.7, and then 5, 3. So this looks like this. So we have this weird V shape, we have this weird fallen parabola shape, and we have our graph. Then it says state the domain and range. Okay, the domain is weird because the domain of the first graph is -infinity to 0, but it stays with a parenthesis, not a bracket, because it doesn't equal 0. The domain of the second graph, they don't touch, starts at 1/2, and it equals 1/2. That's what we figured out here. And it goes to infinity. So we have to join these two, and there's this little gap between 0 and 1/2 where our function is not graphed at all. We have this weird gap. As for the range, notice they both hit down at 0. The range is our y values. The range is going up. Range is up and down. Domain is left and right. The range for both of them, they don't go into the negatives. No negatives are touched in the graphing. They both go up, though, towards positive infinity. They both stop at 0, y equals 0. We have a 0 here, we have a 0 here. So the range, they both equal 0, and they both go to positive infinity. The range for both of them are the same. So that's just the range of this function in general. All right, I hope you've enjoyed this video. Please subscribe to my YouTube channel, and I will see you on the next video. Thanks.